So we're now going to look at a geometric tool for finding equilibria and studying our games. And these things are called polytopes. A way to think of polytopes is as higher dimensional polygons. And in fact, mainly we're going to look at, well, in this example, we're going to look at polygons because they're easier to draw. So the definition of what a polytope is simply the following sum over some set of points. If we have a set of points vi, we take all linear combinations of those points. So it's some vector space in R to the k, such that the sum of our coefficients is 1. Okay, and we have lambda I greater or equal to 0, and finally vi belonging to some set v. So v would be some predefined set, and as an example, let's consider 0, 0, a half, 0, a half, a quarter, and 0, a third. Okay. So as an example, if I took lambda to be a quarter, 0, a half, a quarter, then my point v equals a quarter, 0, 0, plus 0, a half, 0, plus a half, a quarter, plus a quarter times 0, a third, which would just be equal to, obviously that's essentially nothing, and so we've got a quarter, and there I've got an eighth plus 12th. That point there would be inside our polytope. But for example, if one of these numbers was different, for example, if this number was just 1, so that the total sum was not 1, then our point would not be in P. Now, this is what our space will look like, so to speak. And we can just draw it relatively straightforwardly, because it's just a two-dimensional space defined by these two dimensions. So we have this point here, 0, 0. Then at a half, and then if we have a third, which will be somewhere around there. So we have this point here, right? We also have this point here, and then finally the other point we're missing is the one that's here at a half, a quarter. And so our polytope is the set of all points either on the boundary or inside the boundary. Okay, and so for example, this point would be somewhere around here. Okay, and indeed any point in this set is a point inside here, or indeed on the boundary. And what these points here are called, they are the vertices. And now here we've kind of defined our polytope based on the vertices, and what we'll see shortly is that there's another way to define the polytope, and then from that get the vertices.